Hi, welcome to Mrs. Park's Algebra 1 class. This is Chapter 9, the first section, Graphing Quadratic Functions. Alright, so why would we do this? Alright, the intervention fountain at Epcot's Future World in Orlando, Florida is an elaborate display of water, light, and music. The sprayers shoot water in shapes that can be modeled by quadratic equations. You can use a graph of this equation to show the path of the water. Alright, so when we're talking about quadratic functions and their graphs, we're talking about graphs that are no longer linear graphs. Linear graphs were line graphs. Now we have a curved graph like this. Okay, so the characteristics of quadratic functions. Okay, you have sturdy linear functions. There are also nonlinear functions. Linear functions, again, remember it has the word line in it. So linear functions are line graphs, line functions. Okay. But there are also nonlinear functions with graph of other shapes. Quadratic functions are nonlinear and can be written in the form function of x, ax squared plus bx plus c, where a is not 0. This form is called the standard form of a quadratic function. Okay, so here is a standard form. Okay. Ax squared plus bx plus c. Okay, this is called a quadratic function in standard form. The shape of the graph of quadratic function is called a parabola. Parabolas are symmetric about a central line called the axis of symmetry. Okay, so what does that mean? This parabola, it's a curve, but it's not just any curve. It has a symmetric. And that means it's exactly the same. If you cut it in half, this half is same as the other half. Okay, symmetric. And that point there, that red line that goes through the middle, that cuts it in half, is called the axis of symmetry. Now, the axis of symmetry intersects a parabola at only one point called the vertex. So here's the vertex right there. Okay. All right. So here are some equations that you need to look at. Alright, so again, this graph is called a parabola, okay, and it's formed by using a quadratic function in standard form. The axis of symmetry. So this line here that cuts through the middle, okay, there's an equation for that line, and that equation is x equals negative b over 2a. Okay, so this is one important equation that you need to know. Okay, x equals negative b over 2a. The y-intercept. Okay, the y-intercept is where it intercepts the y. Intercept means meet. So where does it meet on the y? Okay, on the y-intercept, the y-axis where it meets on the y, that's going to be the c that you see here. That number that adds it to the end of this standard form is where it meets the y. All right, so when you have a graph and it's ax squared plus bx plus c, it opens upward. Okay, and it has the lowest point, which has a minimum. Okay, now if you have a graph and a is less than 0, that means it's a negative, then it'll go downward and it'll have a maximum. Whoops. Okay. All right, domain and range. Domain is a set of all the possible values of the independent variable x, and the range is the possible set of values on the y. So when we're talking about domain here, domain is everything that's possibility on the x-axis. And when we're talking about range, here let's put D for domain. And when we're talking about range, range is everything that's on the y-axis. Remember the y-axis looks like a capital Y going up and down, okay? So range is where everything that's possible on the y-axis. Okay. All right, so how do you graph a parabola? All right, so use a table of values to graph y equals 3x squared plus 6x minus 4. State the domain and range. So here's a table. Okay, just like we did for linear functions, if you just give some x values and then plot it in here. So when x is 1, 3 times 1 squared is 3, plus 6 times 1 is 6, minus 4, which is going to equal 3 plus 6 is 9, minus 4 is 5. And that's how they got 1, 5. So they plotted 1 and 5. Okay, so that's the first point they got there. Second one, when x is 0. Okay, that means anytime you have an x, you multiply at 0. So 0, and that's 0, so negative 4. 0, negative 4 is your second point there. Okay. Negative 1, negative 7. Again, you put negative 1 there and negative 1 there, and your y is going to equal negative 7. And you go through all the table, the points, and you have several points here, and then you connect the points, and you have a nice curve right there. Okay. So, and it's asking you state the domain and range. So domain here, so possibility of x's. Okay. The domain is if this graph continues, it's going to get bigger as it continues. That's a terrible graph. I'm sorry. But imagine this graph continuing. And if it continues, you can see the x is going to get larger on each side. So you have all possibilities, all real numbers for domain. Now range, you see y is getting higher and higher and higher, and it can get higher as high as it can. So, but then when you look down here, the minimum for y is at this point, which is negative 7 right here. So y is greater or equal to negative 7. Okay, it can't be anything less than that. So the range has a limit. Domain is all possible, all real numbers, and the range is greater or equal to negative 7. All right, so go ahead and do your turn number 1. Okay, use the table of values to graph y equals x squared plus 3. State the domain and range. Okay, so pause the video. If you want, you can go back to the previous slide by rewinding the video and watching it over again. So here you would put your x and y. Okay, make sure that looks like an XX. There we go. So x and y, and just go ahead and jot some numbers down. So let's do negative 2, negative 1, 0, 1, 2. Okay. Plot in your x's and then find out what your y is. Once you have that, you can graph it by the order pairs. There's going to be 5 sets of order pairs. Okay, make a nice line, a nice curve, and then tell me what the domain and range is. Okay, so right now, pause your video and do number 1. Okay, welcome back. All right, here's example number 2. Identify characteristics from graphs. All right. Find a vertex. Okay, so vertex is either the minimum or the maximum of the graph. Also, you need to find the equation of the axis of symmetry. Okay, and the y-intercept. So there's 3 things they're asking you for. Okay. Find a vertex. Vertex is easy. It's the point right there. It's either going to be the minimum or the maximum. Okay. So because the parabola opens upward, the vertex is located at the minimum point of the parabola, which is right here, which is negative 1, 0. Okay. So vertex is negative 1 and 0. Okay. Good. Second one. Find the axis of symmetry. Okay. So the axis of symmetry is a line that goes through the vertex and divides the parabola into congruent halves. Okay, so it's actually this point right here that's gonna, and this graph is easy to look at and say, oh yeah, that's the midpoint right there that cuts it in half, and that is negative 1. Okay, but if you can't tell, let's go back. The axis of symmetry here, x equals negative b over 2a. Okay, so this is going to be negative b over 2a if you have the equation. Okay, right now we don't know what the equation is, so we're going to just stick with negative 1. Okay, so this answer here is negative 1. Oh, x equals, sorry. All right, y-intercept is where it meets the y, right here. Okay, y-intercept, it's where it meets the y, And that point right there is 0, 1. Oh, I'm sorry. Wait. This is 0. So this is 1. No, this is 0. Sorry. This is 0. Where does it meet on the y? It should be positive 1. So there's an error here. That should be a positive 1, not a negative 1. Okay, where does it meet on the y? It meets right there, and that's clearly 0, 1. Okay, 0, 1. Okay, so we have answered all 3 questions. So let's move on. All right, again, we're going to do the same thing for example B. Find a vertex. Vertex is right here. So what is that point? That is 1, 2, 1, 2, 3. So 2, 3 is the vertex. It has the maximum point. Find the axis of symmetry. So this line here, okay, that's x is 1, 2. So x is 2. Okay, this graph here can be identified as x equals 2. Y-intercept. Right here where it meets the y, and that point right there is 0, negative 1. Okay, so the y-intercept is negative 1. Good. All right, so here's your turn. Find a vertex, axis of symmetry, and a y-intercept. Okay, so you need to have 3 answers for each question, 2A and 2B. So go ahead and do those 2 and 3 answers for each question. So you should have a total of 6 answers from this slide, and come back when you're done. All right, welcome back. We're moving on to example 3. Identify characteristics from functions. Okay, so for the previous example, we identified vertex, axis of symmetry, and the y-intercept from looking at the graph. Now, if you don't have a graph and they give you an equation, we can still find out what the vertex, axis of symmetry, and y-intercept is. All right. So axis of symmetry, remember that's the one that gave you the equation, and that's negative b over 2a. So here, this is a, b, and c. Okay, so b is 4. So put 4 instead of b. And a is 2. So put a 2 there. So negative 4 over 4, which is negative 1. Okay. So x equals negative 1. And that means, okay, just to show you what that means. X equals negative 1, that point right here. Okay. This is where it cuts in half. Okay. So the axis of symmetry is negative 1. To find a vertex, use the value found for the axis of symmetry as an x-coordinate of the vertex. To find a y-coordinate, substitute that value for x in the original equation. Okay, so I found x equals negative 1. So back in here, I'm going to put negative 1 here and negative 1 there. Okay, so negative 1 and negative 1, 2 times negative 1 squared. Negative 1 squared is 1, so 2 times 1 is 2. Okay, so you have 2 here. And then 4 times negative 1 is negative 4. Okay, you have the minus 3. So 2 minus 4, negative 2. Negative 2 minus 3 equals negative 5. Okay, that means y equals negative 5. So when you have negative 1 as an x, your y is negative 5. So that's your vertex right there. So let's find negative 1. And then you're going to go negative 5. So let's just say that that's a negative 5 right there. Okay. So this is your vertex. That means that's the point that has the minimum. Okay. Okay. And then the y-intercept is the easy one. It's right there. So y-intercept is at negative 3. Negative 3. Okay. So y-intercept is negative 3. So now we have all our points. So here's the minimum. That's where it's going to meet on the y. So go ahead and draw that curve there. Okay. So this, before in the previous example, we looked at this graph and we're able to identify the vertex, axis of symmetry, and y-intercept. Now looking at this equation, we're able to identify the axis of symmetry, the vertex, and the y-intercept. Okay. Okay. Let's try one more example. All right. The first thing you do is to find the axis of symmetry with this equation. X equals negative b over 2a. So b is 6, a is negative 1, okay? And you found that x equals 3, okay? Once you have that, that's the symmetry. So again, if you have a graph, x is 3, okay? That means your graph has that as the mid cutting point, okay? Okay, once you find your 3, you're going to put your 3 here and your 3 here, and you have y equals, and when you solve this, you have y equals 13. That means 3 and 13 is your vertex. Okay, so 3, and then let's say 13 is way up here. Let's say that's 13. Okay, so that's your vertex. So you know it's a negative, so it's just going to have a maximum point. Okay, and your y-intercept is 4. So let's say that's 4. Okay, so your graph is going to look something like this. Okay, so one quick tip here. When you have a negative, it's going to be an upside down curve. A good way for me to memorize that, if it's a positive, it's positive. What do you think about when you see positive? It's happy, so yeah, it's a smiley face. If it's a negative, okay, what I'm talking about, if the A is a negative, you don't like negative stuff, boo, frowny face. So that's one way to remember it. Positive is happy, negative is not happy, it's frowny. So you see here it's a negative, that means it's going to be a frowny, boo, it's going to go upside down, okay? That's one way to memorize it. All right, here's your terms 3a and 3b. Same thing, find a vertex, axis of symmetry, and y-intercept. Okay, I'm going to write here for you the equation is negative b over 2a. Okay, so find that first. Once you find that, substitute the x in here and find y, and that will give you the vertex. And this is the y-intercept. Okay? All right, so go ahead and finish 3a and 3b and come back when you're done. All right, welcome back. Here is a quick review of linear functions and quadratic functions. Linear functions, again, it has the word line in it. Okay, so it's a line graph, and this is a quadratic function. It's a curved graph. Okay, degree, first power. They only have first power here. The degree is only second power here. Okay, example. This is what a linear function looks like. This is what a quadratic function looks like. The graph is a line. Graph is a parabola. All right, maximum and minimum values. All right, so this is what we're talking about. If it's positive, yay, it's happy. If it's negative, boo, it's a frowny face. So it's positive, it has a minimum. If it's negative, it has a maximum. Okay. Minimum, something to watch out for. Maximum, minimum values. Don't forget to find both coordinates of the vertex, x and y. The minimum or maximum value is the y coordinate. All right, maximum and minimum values. Okay, so here you see it's a negative, so you know it's going to be boo, it's negative. Okay, so you know it's going to have a maximum value. All right, that's all it's asking for. Does it have a minimum or maximum? Okay, so it has a maximum. Okay, moving on to example B. State the minimum or maximum. Okay, so how do you find that point, that maximum point? It's called a vertex. Vertex equation is negative b over 2a. So negative b, negative 4 over 2 times a is negative 2, so it's negative 1. Okay, so there is your x coordinate, or vertex. Okay, so when you put your x here and your x here is negative 1, then your y, or your function of negative 1 is 8, so maximum value is going to be 8. So in other words, if you find this point, the vertex is what? Negative 1 and 8. Okay, that means this point here is going to be 8 on the y. Okay. State the domain and range. Again, the domain is the x value. It's going to, if this keeps going on, it's going to be all real numbers. Okay. Range. Okay, so the maximum is going to be 8, So it's going to be less or equal to 8. Okay. Oops. Go ahead and do numbers 4a and 4c. Consider this equation, the function g of x. Okay, determine if it has a maximum or minimum. State the maximum or minimum value. State the domain and range. Okay, if you want to rewind the video and come back when you're done. Okay, so key concept. This is the steps that you need to look back at if you're trying to graph a quadratic function and you're not sure. Go back in your textbook. This is right out of your textbook. Here are the 5 steps you need to take. First thing, find the equation of the axis of symmetry. Again, axis of symmetry, negative b over 2a. Okay, so that should be easy one. Once you find that, find a vertex, okay, and determine whether it's a maximum or minimum. Positive, negative. Okay. Finding the vertex, you put this back in the equation. That's your x, and find your y. So vertex should be in x and y form. Okay. Y-intercept, it's when you have the equation. Okay. The C part right here is the y-intercept. Use the symmetry to find additional points in the graph if necessary. Okay. That means if you want to find other points, but if you have these points, then you should be fine to graph. Connect the points with a smooth curve and just connect it and make sure it's a nice curve. All right. So how do we do this? Graph this equation. All right, axis of symmetry. Here's your equation again. Find your x. Once you find your x, go here and there and find your y. Okay. So we know now it's -2 and -1. Okay. That's the vertex. All right. It's a positive, so it's happy. Yay. So it's a happy face. All right. -2 and -1. -2, -1. Okay, that's the vertex. Okay. So it's a happy face, you know that's going to be a minimum. Okay. So, and it's going through this point here, but this is going to be the actual minimum. All right. Next, find the y-intercept. 3 is the y-intercept. So 1, 2, 3. Let's say that's 3 right there. Okay, next. The axis of symmetry divides a parabola into 2 equal parts. So if there's a point on the one side, there's a corresponding point on the other side. That is the same distance from the y, the same distance from the axis of symmetry, and has the same value. All right, so actually here's a better graph. So there's the vertex, there's the y-intercept. So they're saying if you have these 2 points, the line of symmetry, it should have, if it's two blocks away, there should be 2 blocks away to the left as well. So that's your other point. Same as here. If you have a unit here, 1 block to the right, then same 1 block to the left. Okay, so there's your points. On the next step, step 5, is connect the points with a smooth curve. Okay. So if you were to do this on your own, so from here to here, it's 2 units, so 1, 2 units there, okay, which should be right here. So then make a smooth point, curve, and graph. Okay. Okay. So here's your turn, and it's the last. I apologize. It's supposed to be a long lesson, but it is an important one. So go ahead and do 5A and 5B. There are 2 graphs that you need to do here. So go ahead and do that. If you need to, go back to these steps. There's step 1, 2, 3, 4, 5, and it's also in your textbook if you need it. Okay, thanks for watching.